Now we start with the measurement of physical quantities. Measurement is defined as measurement is an integral part of quantitative and not qualitative. It is a quantitative observation. And what is a physical quantity? Characteristics of matter or energy that can be expressed as measurable quantities are called physical quantities. Now, the second thing that we have to understand is what is a standard value? What is a standard value? Standard value means 1 meter or 1 centimeter. These are all standard values, because when we state 3 meters, that means it is 3 times the standard value, 3 times the standard value. Now, to measure a physical quantity, the unit chosen should be, number one, you can write is of convenient size. Number two, unambiguous. Three, reproducible. Invariant. Under change of space and time. 4, 5, acceptable to all. So these are the criteria to choose a unit. We all know about the fundamental units and derived units. Just for revision, fundamental units are 7 in numbers. The first one is length. The length basically expressed in meter or in centimeters. The second one we can tell is mass, expressed in kilograms or grams. Feet, here we can write pound. Length, mass, time. Now time remains the same for all, second, second, second. Fourth one we can write electric current. Electric current unit is ampere. Thermodynamic temperature, we can write only temperature, expressed as in Kelvin. The sixth one is amount of substance, expressed in mole. And number 7 is luminous intensity. Expressed in a unit called candela, whose short form is CD. Short form of mole is MOL, Kelvin K, and that of ampere is only A. Now straightforward move into the topic of dimensions. There are 7 numbers of fundamental units, and the rest, all the units are known as derived units. Rest all are derived. Dimensions. We all know how to find dimensions of physical quantity. What is a dimension? A dimension of a physical quantity is its relationship with the 7 quantities, each of which has been assigned by convention a base unit. And now these fundamental units are also known as base units. Suppose we have to find the dimension of we find dimensions of derived quantities and not fundamental quantities. Suppose the dimension of force. First we have to know the definition of force. What is it? Mass into acceleration, mass into velocity by time. That means mass into displacement by time square. These three are all fundamental units. So we write m, l, t minus 2. Let us take a few more examples like pressure. What is pressure? We all know it's force by area. So force, we have already derived it. So it comes out to be m l minus 1 t minus 2. A third bracket is very essential. Without a third bracket, it doesn't mean a dimension. One or two more cases. Suppose angle. Now this is a unique case. What is an angle? Angle is an arc by radius. We all know what is an angle. So arc is a length, and radius is also a length. Now the dimension has come out to be 1. Now when the dimension is 1, we state it as a dimensionless quantity. But angle has unit, radian. So if a question comes, name a physical quantity which is dimensionless but it has got a unit, the answer will be angle. Similarly, solid angle, you can take it as another question. Solid angle, same thing will happen here. It will be solid angle means area by radius square. Area means L square, radius square is also L square. It turns out to be 1, which is also a dimensionless quantity. It is a dimensionless quantity. Dimensionless quantity has a dimension of 1. But again, similar to the above case, solid angle has units of steradian. Next, we start with the dimensional analysis. Now, what is dimensional analysis? First is the conversion of the value of a physical quantity from one system to other. One system to other means we know about the systems of SI system, CGS. SI system is MKS, we all know it, and another is FPS. The first two systems are from France, and the last one is the British system. Conversion of one system to another. Now we all know 1 joule is equal to 10 to the power 7 args. Now how to prove it using dimension analysis? We have done this problem using units, but using dimension analysis We have to first find out the dimension of joule. Means it is the unit of work. So dimension of work ml square T minus 2. Now changing this system from SI to CGS, 1 into, suppose, M2 L2 square equal to N into one is in joules and N is in arcs. Now we have to find out the value of N. Therefore, N is equal to M2 L2 T to the power minus 2, M1 L1 T1 to the power minus 2. So M2 by M1, L2 by L1, N2 T2 by T1. So now this side is SI and the right hand side is CGS. So M2 is in SI, so we write 1 kg by 1 grams, as M1 is in CGS, 1 meter by 1 centimeter, 1 second by 1 second minus 2. (1,000 grams by 1 gram). Convert 1 kilogram to grams. 100 centimeters by 1 centimeter. We have a square and it turns out to be 1. So 1000 into 10 to square means 10 to the power 7. The value of N comes out to be 10 to the power 7. So 1 joule becomes 10 to the power 7 arcs. The second part of dimension analysis is to check the correctness of an equation. Let us take a very simple example. V is equal to U plus AT. You all know it. Now V is final velocity, is initial velocity, acceleration and time. So the left hand side for velocity, the dimension we know it is LT minus 1, and the right hand side U, the dimension is LT minus 1. AT, A means acceleration, LT minus 2 into T, which comes out to be LT minus 1. So U plus AT becomes LT minus 1 plus LT minus 1, LT minus 1. Now LT minus 1 does not become 2LT minus 1, because suppose 1 meter plus 2 meter is 3 meters. This is meter, this is meter, turns out to be, the answer is also in meters. So proved LHS equal to RHS, or LHD, suppose RHD, left hand dimension, is equal to the right hand dimension. The last and to check the relationship among different physical quantities. In simple terms, it means to derive formulas. In simple words, it is to derive the formulas. We all know the time period of a simple pendulum is 2 pi root over L by G. Now, how to find this out using dimension analysis? We have a pendulum. Length of the thread L, mass of the bob is M, and attraction or gravitational attraction or acceleration due to gravitational attraction is G. So the time period depends on these three factors. One is mass, second one is length, and the third one is g, or acceleration due to gravity. Now suppose we write it as m to the power x, l to the power y, g to the power z to understand the powers of dependency. So t is equal to k m to the power x, l to the power y, g to the power z. Now we write the dimensions of the respective quantities on both sides. So m to the power 0, l to the power 0, t to the power 1. Anything to the power 0 is 1. Dimensional of a constant